Chapter 3 is called Atoms, the Building Blocks of Matter. So we're going to expand on the atom a little bit here and talk about what it's made up of or comprised of, being the proton, electron, and neutron, and also the history behind those three, what we call subatomic particles. So three important laws here that you'll want to know the definition of. The first one you've heard of before, the law of conservation of mass. And this is saying that mass is neither created nor destroyed during chemical reactions. So you're never losing it or creating it. It's just being transferred somehow. The second one, the law of definite proportions, says a chemical compound, let's take H2O for example, recall what a compound is, contains the same elements in exactly the same proportions by mass. What this means, if you go to the next slide, we're looking at water. No matter how much water you have, whether it's just a drop of water, or if you take a pool of water or a lake of water, it will always be in this 2-to-1 ratio. And this law does mention the mass, which we'll talk about from the periodic table. Hydrogen has a rounded mass of 1.01 grams per mole, and oxygen has a rounded mass of 16.00 grams per mole. So the way we get this 2 down here is because we have 2 hydrogen atoms. But no matter how much water you have, this law is saying it's always going to be in the same ratio. The third law, which is a wordy law, but it is important. It says if 2 or more different compounds are composed of the same 2 elements, the ratio of the mass of the second element combined with a certain mass of the first element is always a ratio of small whole numbers. So an easier way to remember this law, it says about 2 or more different compounds having the same elements. So if you go to 2 slides over, the 2 compounds I chose to illustrate this, water and something you have at home in your medicine cabinet, hydrogen peroxide. Notice they are different, right? Water is H2O, hydrogen peroxide is H2O2. So they are different, but they are the same elements. Water has hydrogen and oxygen, and then hydrogen peroxide has hydrogen and oxygen. But the ratio is different. There's 2 oxygens in hydrogen peroxide, and only 1 is water. And the law just goes on to say that it's always going to be in small ratio of small whole numbers. So if you look at the mass ratio, instead of 2 to 16, it's 1 to 8. We're just reducing there. And instead of 2 to 32, we get the 32 from 2 oxygens, 16 times 2. Instead of 2 to 32, we go to 1 to 16. So that's what that law is saying. You'll want to know the definition for those. We go to someone who you have heard of before, or should have heard of before, John Dalton. And he has 5 main points to his atomic theory. And this was back in 1808, which truly is not that long ago. It's only 200 years. So in the big scheme of things, it's not that long ago. But you want to know these points to his theory. His first point says all matter is composed of atoms. His second point says atoms of a given element are identical in size, mass, and other properties. So all of the atoms of, pick an element, pick gold, he's saying every single element or atom of gold is identical in size, mass, and other properties. He also said atoms cannot be subdivided, created, or destroyed. Atoms of different elements combine in simple whole number ratios to form compounds. And lastly, he said that in chemical reactions, atoms are combined, separated, or rearranged. So those were the points, the 5 points to his theory. And we will learn on the next slide that he was wrong with some of them. So maybe you want to pause the video and think about which ones you think he was wrong with. But you do want to know those 5. So years later, we get to the modern atomic theory, what we know today. He was wrong in saying that you cannot divide an atom or you cannot split an atom. We can do that. That's how we get our atomic bombs. If you split an atom, a lot of nuclear fusion in an atom. So you can divide them. And also, he was wrong in saying that all of the atoms in an element are the same. That's not true. That a given element can have atoms with different masses, and we call this isotopes, or we call these isotopes. You've talked about those in bio class, and we'll talk about those in chemistry class too. So these 2 points he was wrong about. So I could ask you on a test, what 2 points was John Dalton wrong about? And there would be those 2. Everything else, though, he was correct on. So he did know a little bit about what he was talking about. So let's give him some credit. There's a meme for you. Okay, let's talk about the structure of the atom. So atom, we know from chapter 1, it's the smallest particle of an element that still retains that property. And there's 2 regions to the atom. There's the nucleus, which is a very small region, and it's at the center. It contains our protons and our neutrons. So if you picture the neutron, the nucleus, it contains our protons, which are positive, P and P. The number of protons is determined by what element you're using, which we'll talk about. And it contains neutrons. I put those as zeros because they are neutral charge. They don't have a charge. On the outside of the nucleus, we have our electrons. They are negatively charged. Together, protons, neutrons, and electrons, they are called subatomic particles. Vocab word. So all 3 of those together are called subatomic particles, and they all make up the atom. Now, we'll see that we did not always think of the atom this way. That some scientists actually thought these electrons were in the nucleus. I mean, there was a point where we didn't even know these subatomic particles existed. Protons, electrons, and neutrons. But we've come a long way. So this is a generalized idea of what the atom looks like. Again, this is your nucleus, and then protons and neutrons inside, electrons on the outside. So how did we come up with all this? Well, the electron was discovered by someone called J.J. Thomson. And he used what's called a cathode ray tube to discover the electron. Cathode ray, you would find those in very old television sets. Very old television sets would have those. And what happens is electric current is passed through different gases at a very low pressure. And you'll get your fluorescence like this, and then it comes through the TV and it shows up on the screen, and that's how you get your image. That's how you would watch TV back in the day. It's much different now. Please watch this video. It really shows it well, how we found out that they were negatively charged. Very important. Please click on that video and watch that. Okay, from this model, he found that the electron has a very large charge to mass ratio. That's not totally important for us. That's more just information. But he had something called the plum pudding model. So he thought these electrons, as I said in the previous slide, 2 slides ago, were in the nucleus. Kind of in this pudding, he called it, plum pudding model. So we know, again, the electrons are on the outside, but he envisioned them on the inside. That's the plum pudding model. He was wrong.
Just a reminder, rapid response team will be...
Another meme for you. Our next scientist is Robert Millikan. He determined the charge of the electron using what's called the oil drop experiment. Together, J.J. Thomson and Millikan found the mass of the electron. And you can see how very small this is, times 10 to the negative 31st. So move your decimal point here 31 times to the left. That's a lot of zeros before. Very, 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 very small. The mass was so small, in fact, that Millikan knew that somehow something else had to come into play here to make up the mass of an atom. We know atoms' masses are very small too, but there had to be something else to bring the mass to the table. And that's how we started talking about protons. We also knew that atoms were neutral. So if we had this negative charge here, there had to be a positive charge somewhere to cancel that, to get to neutrality. Please click on this video and watch this, because this will show the oil drop experiment very well. So please do that. And really the last scientist we're going to talk about is someone called Ernest Rutherford. He led to the discovery of the nucleus through his gold foil experiment. Again, please click this video and watch that, because it will show you the gold foil experiment. 3 things he led that were important about the nucleus. Found out it was very small, it was very densely packed, and it was indeed positively charged. We know that because it consists of protons and neutrons, and again, protons are positive. An atom is electrically neutral because it contains equal amounts of protons and neutrons. So for the beginning of chemistry this year, all of our atoms are neutral. So if we have an atom here, here's the nucleus, and it has 3 protons, we know that there is going to be 3 electrons on the outside. It will not always be like that this year. We'll get to what's called ions. But for now, they are equal. The proton, very important, determines the atom's identity. Protons tell us what element we're working with. And we'll refer to what's called the atomic number for that. This is just a recap slide for you, so you can kind of summarize everything regarding the subatomic particles.